This is an engineering mathematics question. There are two sets S1 and S2 defined as the following, and need to determine which of these statements about these two sets is or are true. The value of n is given to be greater than or equal to 2. Now based upon these facts, let us evaluate what the resulting sets are. Set 1 is a set of all n cross n matrices having the entries from set having elements A, B and C. So how many such matrices will exist? That will all those matrices will be forming this particular set. The set is having all n cross n matrices, and value of n can vary. It is given to be greater than or equal to 2, so we can set the value of n to be 3, 4, 5 and so on. And for every value of n, let us say for 3, we will be having 3 cross 3 matrix, and each element of this matrix will be coming from this set. So this 3 cross 3 matrix, it has 9 elements, and each of these elements is coming from this set. So how many 3 cross 3 such matrices will be there? There are 9 elements and each has 3 choices, so it will be 3 to the power 9. Similarly, if it were a 4 cross 4 matrix, then there will be 16 elements, each has 3 choices, so 3 to the power 16 and so on. If we generalize it for value of n, we get 3 to the power n squared as the cardinality of this set S1. It will have 3 to the power n square such matrices, which implies that for a given value of n, there are 3 to the power n square such matrices which satisfy the given conditions. Okay, now we're done with set S1. We have found out its cardinality. Now let us move on to set S2. It is a set of all functions from this set, let us call it A, to this set B. Now this set A, it is having elements from 0 to n square minus 1, which means n square elements. That is its cardinality. And set B is having just 3 elements. We have to find out the number of functions from set A to set B. Now what is a function? Function is such a relation from set A to set B such that every element of set A will be mapped to some element of set B. It is possible that multiple elements of A map to the same element of B, but it is not allowed that one element of A maps to multiple elements of B. This kind of thing is not allowed. This is allowed. And another condition is that no element of A should be left out. It is not allowed that if it is having 3 elements, this is having just 2. So this is how we map and this is left out. That's not allowed. Either you can map it to first one or second one anyways. So it is allowed if elements are left out in B, but none of them should be left out in A. That is the condition. So now our set A is having n square elements and set B is having 3 elements. So how many functions can be formed? That is the question. So what we can do is we can pick up every element of A one by one and map it to one of the elements of B. So each element of set A has 3 choices, either 0 or 1 or 2, and there are n square such elements. First is having 3 choices, second is having 3, third is having 3, so on n square times. Each element is having 3 choices. So we are having 3 multiplied by itself how many times? N squared times. So what does this become? It becomes the same thing, 3 to the power n squared. So our set S1 and set S2 both are having the same cardinality, which is 3 to the power n squared. Now let us look at the options and determine what is correct. There does not exist a bijection from S1 to S2. What is a bijection? It is such a mapping which says that there are different types of functions. Let us note them first: injective, surjective and bijective. Injective means one-to-one mapping. Every element of set S1 has to be mapped to like one element of set S1 maps to one element of set S2. There is a one-to-one relation. And surjective means onto, which says that no element of B should be left out. All of them should be used. So in this case, from S1 to S2, if there has to be a surjective mapping, then all elements of S1 will be used, all elements of S2 will also be used. That is called surjective. And bijective is a combination of injective plus surjective. It is 1 1 on 2. So the first option is saying there does not exist a bijection from S1 to S2. There can exist a bijection because see, S1 is having the same number of elements as S2. So it is possible that we create such a mapping that it is 1 to 1 as well as on 2. There are multiple mappings possible, but there also exists one particular matching in which the relation will turn out to be both 1 1 as well as on 2. We will use all elements of S1, we will use all elements of S2, and we will ensure 1 to 1 mapping. That is definitely possible. So there exists a bijection from S1 to S2. So this option A is incorrect. Now B is saying there exists a surjection, which means on 2. Definitely both are having same number of elements, so we can create a surjection between them. There exists a bijection, definitely. Surjection and injection both can exist, so they will combinedly make up bijection. There does not exist an injection. No, it is false. Injection does exist. 1 to 1 relation can be formed. Now, it is not necessary that we always have to form 1 to 1 relation and on to relation between them. They are just asking if it can exist or not exist. So we are answering that yes, it can exist in particular cases, in a particular way if we create that mapping. So it is definitely possible to have a bijective relation between S1 and S2. So the correct answers are B and C.